Okay, so the purpose of this video is to try to help you get a jump start on typing up homework in your math classes, in particular for me in Math 300. So the standard typesetting software that pretty much all mathematicians, computer scientists, economists, physicists use is called TeX. Okay, so TeX is like a typesetting system, as it says here, that was invented by Donald Knuth in the 70s. And most of us use LaTeX or LaTeX, which is built on top of TeX. Okay, so let me not get too technical about the differences between TeX and LaTeX. For our purposes, they'll be the same thing. Okay, now in trying to learn how to use LaTeX or LaTeX to type up your homework, it can be sometimes a little bit difficult for a newcomer to jump in because LaTeX is a logic-based typesetting system. In other words, you sort of tell LaTeX the structure of your document and the contents of your document, and then LaTeX handles actually turning it into a document. Okay, most text editors that you're used to, things like Word or whatever, are called what you see is what you get, or WYSIWYG editors, which means that you're physically changing how you manually change how the document looks. You add spaces or you add tabs or whatever, right? You figure out the numbering maybe, right? So if you were to say you have like theorem 1 and theorem 2 in your Word document, and then you want to switch the order of them, probably most of you at this point would just change theorem 2, you copy and paste it up, and then you change the numbering from 2 to 1 and the numbering from 1 to 2. Okay, LaTeX is a logic-based, structure-based way to typeset your document. So in LaTeX, you'd have like theorem here and theorem here, and LaTeX would automatically number them theorem 1 and theorem 2. Then if you change them around, LaTeX would automatically handle the numbering as well. Okay, so LaTeX is extremely powerful, and it's extremely good at typesetting mathematical formulas, which is why it's the standard in mathematics, economics, physics, computer science, etc. But it's difficult to jump into, so let me help you figure out how to get started. Okay, so there are many LaTeX editors out there on the internet. If you just Google LaTeX editor, you'll see lots of options. So when I'm using LaTeX, I will use TeXworks. I'm on a Windows machine. And so what you're seeing here is on the left side is like the source code. So this is me telling LaTeX how I want the document formatted and the contents that I want in my document, right? And then when I compile this source code, it produces a PDF on the right, which is what the document ends up looking like. Right? So there's, for example, here in the source code, I have emphasize. This says that I want to italicize the word emphasize. Right? This is how I tell LaTeX to italicize it. And then in the text, LaTeX handles the italicization of the word. Okay. But if this is your first time using LaTeX to type up mathematics, I maybe wouldn't recommend actually going out and downloading and setting up a TeX editor, because there's actually a very good one that you can just access from your web browser, so you don't need to install anything. And many people use it, including myself, and this is Overleaf. Okay, so one of the main benefits of Overleaf is that you can collaborate on the same TeX document with other people. So if you are doing some collaborative work, it's very useful. But also you can just use it as your standalone TeX editor, and everything gets saved, and you can get a free account. Okay, so you go to the Overleaf website and you log in. Let's log in here. So of course I already have an account, but you can create an account. And as you can see, I have several LaTeX documents with my collaborators, right, spanning back at least 2 years ago. So I genuinely use it, but let's start a new project, right? So when you start a new project, let's suppose I want to start homework 1, okay? So I started a blank project. So what Overleaf does is it populates it with like a very bare bones template. But what I've done for you is I've created this homework template. And so and I'll make this available on my website. And so what you can do is you can just copy and paste in this template into here. Okay, so now I have the template copied and pasted into here. So in Overleaf, if you want it to compile your document, you have to hit this recompile button. Takes a little bit of time, but then it creates the document here. Okay, so what you might notice is that this document is pretty short given how long it seems like this source code is. But that's because every LaTeX document starts with a long preamble that sets up the settings of your document and sets up some commands that you might want to use. And so all the stuff up here is preamble, which you can choose to just ignore, and then you can start here, right? So where it says your name, and it says your name here on the document. Okay, so let me make this text a little bit bigger so that we can see it easier. This is also very doable in Overleaf, maybe 22. Here we go. Okay. So you can choose to just ignore the preamble, which I maybe recommend that you do when you're first starting out, because I've tried to set it up for you. But while I'm here, let's go through the preamble to see what the different parts of it are. Okay, so first of all, the way to comment in LaTeX is to use %signs. Okay, so if you put %signs at the beginning of a line, then LaTeX will just ignore when compiling. And so I've put comments in this template as comments starting with %signs. Okay, so like I said here, every LaTeX document begins with a preamble, which sets up the document. And I've tried to explain the preamble, but you can ignore it if you want. Okay, so the very first thing in every LaTeX document is you say what document class you want to use. Okay, there's many different document classes, but for our class, for homework, probably article is fine. Okay, you can change this up, but let's not worry about that. So I would just leave the document class as is. Okay, after it, you tell LaTeX what document class you want. You can then add in a bunch of packages, which will give you more functionality. Okay, so LaTeX itself doesn't know about typesetting mathematics specifically, but we can load some packages that will include a lot of mathematics setup, and then the mathematics will type that beautifully. Okay, so I've loaded in a bunch of standard packages that I like to use. So for example, AMS Math. AMS here means American Mathematical Society. So this is the AMS's math package, which includes a lot of stuff. You don't need to worry about it. I've just loaded in these packages. Note that if you are trying to use some kind of new command that you found on the internet, you might need to load a package in order to be able to use it. Okay, so you might eventually add some more things to here, but I've just added some of my favorites that I personally like to use, and which should be enough for the homeworks in the classes that I teach anyway. If I needed something more, then I would tell you. Okay. The next thing that generally people put in the preambles is they put a bunch of custom macros. Okay, so you don't need to include any custom macros, but I've included some that I'm going to use. And the nice thing is just that if there is some command that you need to type out many, many times in a document, and it's kind of long, you can have like a little shorthand by creating a macro for it. Okay, so for example, here I've created a new command, and the command is \R. Okay, so this is the macro that I'm defining. And what if I type in \R, this macro will just replace it with \mathbbr. Okay, so instead of typing this every time, I can just type in \RR. Okay, and this command will create the Blackboard bold R that you've seen used for the real numbers, like in calculus. Right, so maybe I can even show you in the document. So so I just double clicked on the document, and that took me to the point in the source code where that is. That's a very useful feature in Overleaf. So let's type in, say, the real numbers are, and then I'll type in mathbbr. Okay, so two things to note here. If you want to type math, you put it inside of $signs. Okay, so $signs will delimit the mathematics in your thing. And here I've typed in the command for math Blackboard bold R. So this should create a piece of mathematics typesetting with a bold R. Okay, so to see it, let's recompile the document. And you see here, the real numbers are, and then you get this math symbol, Blackboard bold R. Okay, but since I've also defined the macro that replaces this with a shorter command, I can say, or we can use, again, I'll use $signs to limit math, and I'll use this \RR, which is a command that I defined. All right, let's now recompile and see what this looks like. Or we can use, and then you get the exact same symbol. Right, so instead of typing math BBR every time, if I know I'm going to type it a lot, I'll create this macro, and this makes it much quicker to type that in. Okay, so back to the preamble. I loaded my packages, and now I've defined some common macros. In future homework assignments, what I'll do is I will give you the tech template for the homework assignment. So if I've used new macros, you should have them. Okay, so it will build on top of this first one. So every time I upload a new problem set, you'll have the commands that I use, and then you can see them. Okay, so we'll learn more commands as the quarter goes on. Okay, here I've set up some macros that accept arguments. Okay, so for example, this command set, I've created a new command set, which takes in one argument. And what it does is it sets up the set braces with braces of the correct size, and it puts the argument inside of it, right? So let's see that in action here. So let's say I want to create the set of the set containing the element x, right? The set containing the element x. Okay, so anytime you want to talk about math, you put it inside $signs, right? So this x will typeset as a math x. So the set containing element x is, and then I create a new macro. This macro is set, and it accepts one argument. So let's put x inside of there, and let's see how this typesets. Okay, so I recompiled, and we can see the set containing the element x. So notice that this x is typeset like a variable, not like the letter x. And then my macro has created a set with the x inside of it. Okay, so you'll want to play around with these macros as we go. But I've just created some that I think will be useful to you. In particular, I've created some new environments where you can type in solutions and proofs. Okay, so I'll show you this in a second. And here's just some tips I have on types anything. So if you're doing a proof, you can actually ignore this if you're going to use the proof box that I provided. I've mentioned here that if you want to type in math, you put it inside of $signs. But if you want to create math in its own line, then you'll put it inside of \brackets. I'll show you this in a second. And then here are some commands that we'll use at least at the beginning, mostly throughout this class. But like I said, you'll find lots of relevant commands in the question prompts as I upload them to the class. Also, probably the biggest thing to know about using LaTeX is Google is your best friend. So if you want to know how to type something in LaTeX, the first thing you should do is Google, I don't know, subset symbol LaTeX, right? So maybe we should even try that, right? So you want to know the subset symbol, you typeset subset symbol LaTeX. And then, oh wow, this is even better than I thought. So Google says here, here's the LaTeX commands to create these symbols that you want. Okay, also in the notes for the class, I will include lots of commands for how to get the symbols that you want. I'm trying to make this as easy as possible for you to learn how to use LaTeX, because actually that could be a very valuable skill that you could learn just in trying to do your homework for this class. Okay, so that's the preamble. It's a bit of a long preamble, but like I said, you can just ignore it if you want. Now we're going to start the document. And every document, once you've done the preamble, starts with begin document. And at the very end, it ends with end document. Okay, so everything within this begin document, end document environment here will end up being in our document. Okay, so I've set up the top. You can customize this if you want, but you type in your name here. and the date here. Let's just put a random date, June 6th, 1999. So when I recompile, now you can see my name is here, my name is here, and the date is here, right? So you can change this as you change your assignments. Then, math. Okay, so let me try to explain things as we go. These double backslashes that will end, this will end a line and start a new line for you. But you don't need to use it all the time. Again, you really should play around with this. Here, I've created a centering environment. So that's why I've gotten this Math 300 Homework 1 to be centered. And then also I've said I want the font to be larger. So inside these braces, we use braces to delimit logic in LaTeX. So inside these braces, everything, all this text will be in a larger font. Okay, now we'll get to the actual part where you're typing up your homework. Okay, so as you notice, this template that I've set up, there's two questions on this homework assignment, 1 and 2. And then even within question 2, there's 2 parts, A and B. Okay, now the way to set this up in LaTeX is if you want to create a numbered list, you use what's called the enumerate environment. Okay, so this starts with begin enumerate. This says I want to start a numbered list. And then each time I put an item, it will give me the next number on the list. Okay, so let's start maybe a new item here. So if I say item here, this is the new question 1, and I recompile it, you'll see that now my list has 3 items on it. My first item is 1, this is the new question 1, and LaTeX has automatically handled the numbering, right? So I didn't physically, manually change the numbers of these 2 parts, right? These before were 1 and 2. Just by adding an item here, LaTeX has handled the numbering. So now this is the first new item in the list, this is the second, this is the third. Okay, even within this third item though, I have 2 sub-items, right? I have 2 parts, A and B. So this is the start of my third item. Here's the next item in the list. And then I just created another enumerate environment inside of that. And in fact, LaTeX even handled the fact that this should be A and B rather than 1 and 2. Right? So LaTeX has a standard way that it does the hierarchy of numbered lists. Okay, and then because before I began an enumerate environment, I also need to end this enumerate environment. So this one ends the A, B for part 3, and this one ends the overall numbering. Okay. So now let's go back to question 1. This is the new question 1. So this second question, we already saw us typing this in. So I guess this is now question 2, right? By the way, you could also set up a macro that would automatically number this. This is just a little flex here. So let's call this, now you shouldn't worry about this yet. So now you see it says, this is question 2, right? If I were to add an item before it, this is the new question 2. Because I've set it up, you see now this automatically changed to question 3. Okay, but I'm trying to do something fancy here that you will not need to worry about when you're typing up your homework. Okay, so I'm just trying to show you the power of it, but you shouldn't worry about stuff like this until you're more familiar with LaTeX. Okay, so in this item will be the first question on your homework, right? And I will provide the LaTeX source code for your homework, so you won't need to type up the question, but you can see how I typed it up. And then I've created an environment where you can type in your solutions. Okay, so the way that I've set it up is if you type in \sol, that's for solution, and then you put these braces around whatever you type up, this will end up being in like a nice little solution box that starts with the word solution. Okay, so right now I have nothing inside the solution box, so it just creates the solution box that says solution. But let's say now I want to type up some mathematics, right? So let's say I want to say the line y equals mx plus v has slope m and y-intercept b. Seems like a reasonable thing to type. So inside the solution box, I'll just type the sentence. The only thing I need to worry about is if I'm going to use math, I need to make sure to enter math mode. Okay, so the line, now I want to type the equation of a line, which means I should enter math mode. So I'll delimit it with $signs. So y equals mx plus b. This will typeset it like math. Now I want to say has slope m and y-intercept b. Okay, but since I'm typing math, I want this m to actually be a math symbol, right? I don't mean the letter m, I mean the variable m. This y I also want to be a math symbol. This b I also want to be a math symbol. Okay, so maybe let's look at what it looks like if I typeset it with or without $signs, just to see the difference. So let's remove the $signs here. It will still typeset as long as everything, right? This will typeset as a very reasonable English sentence. Right, so you see the difference between these two, right? So in this first one, I put all the math inside of $signs, which is telling LaTeX that here I mean math variables. Here they typeset as letters. So what you want to do is you want to do the first thing. But notice that the second thing is also readable enough. Oh, I didn't even remove the $signs around the m. The second thing is also readable enough. So if you only end up typing in the second thing, then you still get reasonably readable math text. It just isn't completely correct, but that's fine. Right, note that inside of math text, spacing doesn't matter. So let's say I deleted these spaces around this equal sign, or if I delete the spaces around this equal sign here, you'll see that in math mode, nothing has changed because LaTeX knows to handle it as a math equation, so it'll typeset it as a math equation. Here, though, I've lost the spaces around the equal sign because spaces do matter in text, right? Because they separate different words. Okay, so my hope is that when you're first typing up your homework, what you do is you just take the template that I gave you, and then you can just enter your solutions by using this solution environment, and then just typing as you normally would, but anytime you come across math, you may need to look up how to type up the math that you want. Okay, so let's take a look just at this second part of the template. So I said, here's the next item in the list. So this will be like the second question. I've added this enumerate environment to give me two parts to the question. So this question might have multiple parts. Perhaps the first part is just computational. Okay, so I would want to put my solution to the first part here. So I started a new solution box. Here's my answer to part A. And here I've just showed you that you have lots of powerful mathematics commands. So for example, here I've typeset the integral and an x squared, and it's very easy to do it once you're used to the commands. Okay, so this \int, this is the command for the integral symbol. You can even put limits on it if you want, although it's going to make the equation that I wrote down false. Right, so here I've said, okay, I want the integral symbol with a subscript of a and a superscript of b. So if I compile that, you'll see that the integral symbol that I got now goes from a to b. Okay, so here I've taken the integral of 2x dx, and I've said this is equal to x squared, and the squaring command is just this caret. This gives me a subscript, a superscript rather. Right, if I want, again, anytime you want to use a command in LaTeX, it's probably safer to put in brackets. For example, if I want x to the 23rd power, I need to put brackets around the 23. Otherwise, well, let's see the difference. Right, so let's say if I just did x to the 23, compile it, you'll see that when I didn't put the 23 in brackets, it only put the 2 in the exponent, and then it put the 3 as a number afterward. Okay, so you will run into problems like this as you're beginning to tech, where things don't look exactly the way that you expect them to. But again, if you just Google your issue, or you come ask me about it, then you'll get used to things pretty quickly, hopefully, And then you'll be able to typeset mathematics really beautifully for all the rest of your classes. Okay, so now this thing that I've written down is totally false, but that's fine. There's lots of other, basically any like common mathematical symbol that you want to typeset will have a LaTeX command. So maybe I'd like a fraction. Maybe I'd like a 1/2. So again, I could Google how to typeset a fraction in LaTeX, and what it'll tell me is the command is \frac, and it will take 2 arguments, a numerator and a denominator. Right? So maybe I want a fraction of pi over 2. So to typeset Greek letters, you just type \, and then you type the name of the Greek letter. Okay, so if I type in this \frac \pi 2, this says I want to create a fraction whose numerator is the Greek letter pi and whose denominator is 2. Let's see what that looks like. As you can see over here, I get a nice fraction of pi over 2 here. Okay, the last thing to know is if you want an equation in its own line, which often happens in mathematics, right? You really want to set it apart. In that case, instead of using $signs to limit your math, you'll use this \open square bracket \close square bracket. Okay, so if you do something like this, it creates a new line. And here you don't need to use $signs because this is already delimiting math symbols. Okay, so here I've used sine squared x plus cosine squared x equals 1. Again, to point out one more thing, which is that if you just type in sine, right, this is, I think, the first thing that you would think to type in, something like this. If you type in something like this, the problem is that LaTeX will treat these as 3 variables, sin squared, right? So let's see what happens if I compile this. You'll see that, again, it doesn't look bad. So if you screw up teching something, the results can still look okay, but tech is treating this sin as like 3 variables, right? Like xyz or sin. Whereas if I do \sine, I'm using the sine command built into the AMS packages, and it will typeset as the operator sign. Okay. But this is just a technical point. Again, my recommendation is you just jump in, try to type up your homework, and then as you come across issues, you Google your issues or come ask me. Okay, and then I've also included the fact that maybe you want to emphasize some text. So if you want to italicize text, you use emph, and then you use these brackets to say how far you want your emph to go. If you want to boldface some text, to use boldface, let's say for boldface text, we use, and then the command is text bf, text boldface. This is bold. So if I do this, you'll see it says for boldface text we use, and then this part is bolded in. Okay, last thing is if you have a homework problem that is a proof, then what you would like to do is you'd like to have proof at the beginning and you'd like it to end with a proof box. So I've also included a command that will create this box around a proof for you. And that will be \sol proof, or proof solution. And again, this is inside of brackets, right? So here my proof solution starts, here it ends. I need a bracket to close it at the end, and everything I type inside of here will end up inside of my proof, right? With a square box at the end. Okay, so your first homework assignment, I will upload the template. You can just enter the template. I mean, you can just download the template, copy and paste it into Overleaf, and then use this either \sol proof or \sol command to create this box, and you can just start typing your solution. Hopefully, this helps you get started. Again, my recommendation is jump in, give it a try. As you come up with problems, solve them as you come to them. I would say that most mathematicians even, right? So I've been now a professional mathematician for some number of years. You know, I started learning tech as an undergraduate. I used it all throughout graduate school. I used it as a professional mathematician. Even now I'm learning about how to do things in tech the correct way. So I think it's somewhat a lifelong process. I know lots of very old math professors who I think don't typeset things in the precise, correct way. They still create beautiful looking math documents, and hopefully you will be able to do this too. Okay, so I will post this template to my website. I guess I'll also post this video on YouTube, so a link to this template will also be in the description of the YouTube video.